The James Webb Telescope has recently sent a dazzling message that has left all NASA scientists amazed. The greatest optical telescope in space has been observing various aspects of our gigantic universe for a seriously prolonged stretch of time, uncovering various eccentricities. However, the new picture it has sent has created a wave through the world of science and astronomy. What startling image has the James Webb Telescope captured? Could it have photographed an extraterrestrial spacecraft in the farthest reaches of space? Join us as we explore the alarming new images that the James Webb Telescope has unveiled, images we have never seen before. If you're excited about staying completely informed about news from the universe and its ecological elements, subscribe to our channel, like this video, and turn on notifications. NASA's $10 billion James Webb Space Telescope was launched from the European spaceport in French Guiana. When it arrived at its new grand home, this infrared observatory provided dazzling views of the universe to analysts and stargazers. As the most advanced and greatest space telescope to date, analysts were excited to see the first images captured by the telescope. What they saw nearly left them frozen. When the James Webb Telescope turned its instruments toward the well-known pillars of creation, it captured the famous dust clouds in great detail. These pillars are located in the Eagle Nebula, around 7,000 light-years from Earth. The pillars of creation contain enormous swarms of gas and dust, first imaged by the Hubble Space Telescope in 1995. Since then, the pillars' brilliant light has been revealed, but the new photograph captured by the James Webb Space Telescope uncovers them in even more critical detail. Some stars visible in the new image were absent from the previous image captured by Hubble. Some of these stars formed just 2 or 3 million years ago, marking a significant scientific advancement. The James Webb Space Telescope has also examined the so-called Pandora's cluster in a stunning image, named after the Pandora of Greek mythology. This region, predicted by Albert Einstein in 1915, has astonished scientists as the new images reveal details previously unknown in this part of space. However, it's important to note that this area of space has a formal name, Able 2744, part of the Pandora cluster. This cluster houses a vast assemblage of distinct structures. What makes this image so enticing is that, although this region has been observed before, only the central part was examined by the Hubble Space Telescope. This suggests that various cosmic secrets must still be uncovered in this fascinating area of space. Prior to the James Webb Telescope directing its powerful infrared instruments toward the area, the observing team used the telescope's near-infrared spectrograph and near-infrared camera as part of a deep observation program. Before the ionization epoch, multiple images were taken and then combined into a panoramic view. This image revealed around 5,000 infrared light sources in the Pandora cluster, which is about 3.5 billion light-years away. The image captured by the James Webb Telescope achieved an extraordinary balance between depth and breadth, potentially changing our understanding of cosmic evolution. A highlight of the image is a bright foreground star in the Milky Way, whose remarkable diffraction pattern was created by the telescope's optics. Also evident are distant galaxies, excellent sources of white light surrounded by a hazy glow, forming part of the Pandora cluster. Although human-made technology is indispensable for observing galaxy clusters, astronomers also relied on a natural phenomenon proposed by Albert Einstein in his theory of general relativity, published in 1915. Intriguing discoveries continue to excite scientists and space experts. The James Webb Telescope has captured peculiar cosmic phenomena that even experts cannot fully explain. One such mystery is a series of concentric rings found around a distant star, WR-140, which scientists have yet to completely understand. The image was shared on Twitter by a citizen scientist, sparking a storm of comments and debate. The picture showed WR-140 surrounded by regular, wave-like circles that gradually faded. What was striking was that the circles were not perfectly round, but had a somewhat square appearance. This immediately led to speculation about a potential extraterrestrial origin. However, some analysts argued that it was simply a natural phenomenon that appeared extraordinary when viewed from a single perspective. Sometimes, natural phenomena seem spectacular from certain viewpoints but have simple explanations. Nevertheless, questions remain: why do the rings have that specific shape, and why are they so uniform? These questions have troubled experts like Mark McCaffrian, an interdisciplinary researcher with the JWST Science Working Group and a science advisor to the European Space Agency. He called it surprising in a Twitter thread. He explained that the sharp blue pattern is an artifact caused by optical diffraction from the bright star WR-140. However, He noted that the red bands are real and represent a series of shells around WR140. Despite this, NASA is expected to provide an official explanation soon. Generally, young stars shine bright blue, while older stars turn more reddish as they burn their fuel and cool. Cosmologists didn't anticipate seeing old, red stars in the early universe, which the James Webb Space Telescope was designed to study. Nor did they expect to see galaxies up to 1 billion times more massive than the Sun. In Jankai's opinion, the most massive galaxies in their sample are estimated to have masses between 2 and 4 times less than that of the Milky Way. She described this discovery as astounding since galaxies as large as our own were found when the universe was only 3% of its current age. Leah also mentioned that before cosmologists start adjusting their theories of the cosmos to explain how these galaxies formed so quickly after the Big Bang, they need to ensure that the unusual red spots they are observing are not something else entirely. Nonetheless, alternative explanations would also require completely new ideas. For example, stars in the early universe could have emitted light in unusual ways due to a lack of heavy elements, which are included in current models. The images revealing these enigmatic galaxies were gathered using Webb's near-infrared camera as part of the early Cosmic Evolution Release Science program. The team plans to return to these galaxies and the SMACS 0723 cluster to obtain spectra of light from distant sources. Spectra dissect the observed light into frequencies based on its composition, revealing the chemical and physical properties of its source. Notably, spectra provide very accurate distance measurements, allowing scientists to pinpoint the characteristics of these celestial objects. According to Leah, only a few months after Webb's initial observations, scientists are already being forced to rethink theories about the early universe. Observing the early universe for the first time has revealed something so astounding that it poses challenges for science overall, as it reshapes our understanding of early galaxy formation. Another astonishing image captured by the James Webb Space Telescope shows the Ghost Galaxy, which appears like a glowing whirlpool in space. This new image, based on deep space data, highlights the dust lanes of the galaxy NGC 628, also known as M74, or the perfect spiral, due to its symmetry. The Ghost Galaxy is scientifically intriguing because of the intermediate mass black hole that scientists believe lies at its center. Although this galaxy has been imaged before, by space observatories such as the Hubble and Spitzer space telescopes, Webb's images stand out due to their near-infrared light, revealing vast amounts of cosmic dust. Combined with the power of its unique 18-segment hexagonal mirror, the James Webb Space Telescope, hailed as one of the most ambitious endeavors in space exploration, continues to amaze scientists with its exceptional capabilities and groundbreaking discoveries. Launched with the mission of uncovering the deepest secrets of the universe, the Webb telescope has not disappointed in its initial observations. Distant worlds. Exposing phenomena that were previously unknown, the contributions of the Webb telescope to space science are rewriting our school textbooks. One of the telescope's outstanding accomplishments is its capacity to peer further into space than any other instrument before it. By utilizing its advanced infrared technology and a large mirror with 18 segments, Webb has opened up a new field of research. In contrast to its predecessor, the Hubble telescope, which primarily operated in the visible and ultraviolet spectrum, Webb's infrared capabilities allow it to observe celestial objects obscured by cosmic dust. This ability has proven crucial in its observations of the iconic pillars of creation within the Eagle Nebula. Webb's infrared eye has uncovered unprecedented details of these immense columns of dust and gas, where new stars are born. The telescope's capacity to see through thick nebular material has enabled astronomers to gain a better understanding of stellar birth and evolution. Additionally, Webb's observations of galaxy clusters, such as Abell 2744 and Pandora's cluster, have shed fresh light on the vast structure of the universe. By capturing thousands of galaxies within these clusters, Webb has allowed astronomers to study the formation and evolution of galaxies across cosmic time. Its deep-field images not only expand our understanding of galaxy cluster dynamics but also challenge existing models of cosmic structure and evolution. One of Webb's most intriguing discoveries is the presence of ancient galaxies that defy conventional theories of the universe. These galaxies, observed when the universe was just a small fraction of its current age, have masses that rival or exceed that of the Milky Way. Such findings raise fundamental questions about how galaxies assembled and grew in the early universe. The James Webb Space Telescope, JWST, has rapidly become a centerpiece of astronomical study, significantly advancing our knowledge of the cosmos. One of its most significant achievements is its ability to capture light from some of the earliest galaxies in the universe. This capability is rooted in Webb's advanced infrared technology, which allows it to observe celestial objects that are too faint or distant for other telescopes. Webb's observations have revealed new insights into the formation and evolution of ancient galaxies, providing a deeper understanding of the early universe. Recent images have shown galaxies in various stages of formation and evolution. For instance, Webb has captured minute details of early galaxy mergers, critical events in the life cycle of galaxies that affect their structure and star formation rates. The telescope's detailed observations of these processes are helping scientists piece together the history of galaxy formation, offering a glimpse into how galaxies like our own Milky Way may have evolved over billions of years. In addition to observing distant galaxies, Webb has also focused on nearby celestial objects, such as star-forming regions in our own galaxy. The telescope's ability to see through dense cosmic dust has enabled astronomers to investigate the development and birth of stars in unprecedented detail. For example, Webb has provided new views of regions like the Orion Nebula, one of the closest and most active star-forming regions to Earth. These observations assist scientists in understanding the complex processes involved in stellar birth and planetary system formation. Another significant area of research enabled by Webb is the study of exoplanets. The telescope's infrared capabilities are particularly suited for analyzing the atmospheres of exoplanets, allowing scientists to detect and characterize their compositions. Webb has already begun investigating the atmospheres of several exoplanets, providing data on their temperature, atmospheric composition, and even potential signs of habitability. This information is crucial for identifying planets that might support life and for understanding the conditions that prevail on distant worlds. Webb's contributions to planetary science extend beyond exoplanets. The telescope has also examined our own solar system, including planets, moons, and other small celestial bodies. For instance, Webb has observed the ice giant Uranus, providing new insights into its atmospheric composition and weather patterns. The telescope's observations of distant comets and asteroids are helping scientists understand the early solar system's conditions and the formation of these small celestial bodies. Webb's observations have also led to important insights into cosmic phenomena such as dark matter and dark energy. While these mysterious components of the universe remain elusive, Webb's detailed images of galaxy clusters and large-scale structures provide valuable data that can help scientists infer their properties. By investigating how galaxies and clusters interact and evolve, astronomers hope to gain a better understanding of the role dark matter and dark energy play in the structure and expansion of the universe. Webb's deep-field observations are particularly noteworthy. These observations involve looking at a seemingly empty patch of sky for extended periods, capturing faint and distant objects that would otherwise be undetectable. Such observations have revealed a wealth of information about the early universe, including the formation of the first galaxies and the development of cosmic structures. These deep-field images not only showcase Webb's observational capabilities, but also provide a window into the universe's past. The James Webb Space Telescope has also made significant strides in studying cosmic dust. Cosmic dust plays a crucial role in the formation of stars and planets, making its study essential for understanding various astrophysical processes. Webb's ability to observe dust in high resolution has provided new insights into its composition and distribution, shedding light on how it influences the formation of celestial objects. In terms of technological advancements, Webb represents a significant leap forward from its predecessors. Its large segmented mirror allows it to collect more light and achieve higher resolution images than any other telescope before it. Additionally, its advanced instruments, including the near-infrared camera, NIR-CAM, and the mid-infrared instrument, MIRI, are designed to work together, covering a wide range of wavelengths and providing a comprehensive view of the universe. The telescope's mission is not only to observe, but also to help answer some of the most fundamental questions in astronomy. One of its key goals is to determine how galaxies, stars, and planetary systems formed by observing the universe in its infancy. Webb aims to answer questions about the origins of the first galaxies and stars and how they evolved into the structures we see today. The James Webb Space Telescope has already made a profound impact on astronomy, and its discoveries are expected to continue reshaping our understanding of the universe for years to come. As scientists analyze Webb's data more thoroughly, they will uncover new aspects of the cosmos, challenge existing theories, and refine our understanding of cosmic processes. Webb's contributions will undoubtedly shape the future of astronomical research, expanding our knowledge of the universe in ways that were previously unimaginable. As the James Webb Space Telescope, JWST, continues its mission, astronomers anticipate groundbreaking discoveries that could reshape our understanding of the cosmos. With its advanced infrared technology and unparalleled sensitivity, Webb is expected to address some of the most profound questions in astrophysics, from the origins of the first galaxies to the search for habitable exoplanets. Unveiling the first light of the universe. One of Webb's primary objectives is to observe the universe's earliest light, the first stars and galaxies that formed after the Big Bang. Scientists estimate that these early galaxies began forming around 100 to 200 million years after the universe's birth. However, their exact formation timeline and characteristics remain uncertain. Webb's deep-field imaging, combined with spectroscopic analysis, will allow researchers to measure the composition, age, and structure of these ancient galaxies, offering new insights into the universe's infancy. By capturing the faint infrared glow of primordial galaxies, Webb is expected to fill in the gaps left by the Hubble Space Telescope, which could only observe the universe up to about 400 million years after the Big Bang. This means Webb has the potential to redefine our understanding of cosmic dawn, shedding light on how the first stars ignited and how galaxies took shape over time. Probing the atmospheres of exoplanets. One of the most exciting aspects of Webb's mission is its ability to analyze the atmospheres of exoplanets orbiting distant stars. Using its near-infrared spectrograph, NIR-SPEC, and mid-infrared instrument, MIRI, the telescope can detect chemical signatures that indicate the presence of gases such as water vapor, methane, carbon dioxide, and even potential biosignatures like oxygen and ozone. Already, Webb has begun analyzing the atmospheres of several exoplanets, including TRAPPIST-1 system planets, which are among the most promising candidates for habitability. By studying how starlight filters through exoplanet atmospheres, Webb can determine their compositions and assess whether conditions suitable for life exist beyond our solar system. Future studies may focus on identifying super-Earths and ocean worlds, exoplanets that could harbor liquid water, a key ingredient for life as we know it. Scientists hope that Webb's data will refine our understanding of planetary formation and habitability, bringing us closer to answering the age-old question: are we alone in the universe? Investigating dark matter and dark energy. Despite making up most of the universe, dark matter and dark energy remain two of the greatest cosmic mysteries. Dark matter, an invisible substance that shapes galaxies, and dark energy, the force accelerating the universe's expansion, have long puzzled scientists. Webb's high-resolution imaging of gravitational lensing events, where massive objects bend and magnify light from distant galaxies, will provide new data to study these enigmatic forces. By mapping the distribution of dark matter in galaxy clusters and analyzing how galaxies evolve over time, Webb will contribute crucial data to refine existing cosmological models. This could help physicists determine whether our current understanding of the universe's fundamental forces needs revision. Revealing the birth and death of stars. Webb is also expected to transform our knowledge of star formation and stellar evolution. Its ability to peer through dense clouds of gas and dust will allow astronomers to witness the birth of stars and planetary systems with unprecedented detail. In addition, Webb will study the final stages of stellar life, including supernova explosions, white dwarfs, and neutron stars. By analyzing these dying stars, Webb will help scientists understand the origins of elements like carbon, oxygen, and iron, the building blocks of planets and life. One area of particular interest is the study of Wolf-Rayet stars, massive stars that shed enormous amounts of material before exploding as supernovae. Webb's observations could provide clues about how these powerful stellar explosions enrich the cosmos with heavy elements. Exploring the outer solar system. Beyond distant galaxies and exoplanets, Webb is also contributing to our understanding of our own solar system. It has already begun observing giant planets like Jupiter, Saturn, Uranus, and Neptune, capturing data on their atmospheres, ring systems, and moons. Future observations may focus on icy bodies in the Kuiper Belt, such as Pluto, Eris, and Sedna, helping scientists understand the composition and evolution of these distant worlds. Additionally, Webb will study comets and asteroids, providing insights into the materials that formed the planets and moons of our solar system billions of years ago. One particularly exciting possibility is Webb's ability to detect signs of subsurface oceans on moons such as Europa, Enceladus, and Titan. These moons are among the most promising locations for finding microbial life within our solar system. Pushing the boundaries of astrophysics. With its cutting-edge technology, The James Webb Space Telescope is not just answering existing questions, it is also raising new ones. Each discovery has the potential to challenge established theories, forcing scientists to rethink fundamental aspects of cosmology, planetary science, and astrophysics. Webb's observations could reveal unexpected planetary types, unusual cosmic structures, or unknown physical phenomena that expand our scientific frontiers. Its mission is designed to last at least 10 years, but depending on fuel consumption and system performance, it could operate for even longer, continuing to revolutionize our view of the cosmos well into the future. Conclusion: a new era of discovery. The James Webb Space Telescope represents one of the most significant achievements in the history of astronomy. Its ability to see deeper into space and further back in time than any previous telescope is reshaping our understanding of the universe. From uncovering the secrets of the first galaxies to exploring the atmospheres of distant exoplanets, Webb is unlocking answers to some of the most profound cosmic mysteries. As data from Webb continues to be analyzed, astronomers anticipate an unprecedented wave of discoveries that will not only expand our scientific knowledge but also inspire future generations of researchers, engineers, and space enthusiasts. The telescope's contributions will undoubtedly shape the future of astronomy, providing new insights that were once beyond our wildest imagination. The age of Webb-driven discovery has only just begun.